Hi there and welcome to the second edition of the R for Data Science exercise walkthrough. Today we're going to look at section 3.3, aesthetic mappings. So we're still focusing on ggplot2. Alright, the first question says, what's gone wrong with this code? Why are the points not blue? So first of all, let's have a quick look at the code. And sure enough, we can see that we specify here color equals blue. But if you look at the code, well, that didn't seem to do what the author had in mind. At least if I would have read code like this, I would have expected it to be blue points that we see. But sure enough, we don't. We kind of see these pinkish points. So let's copy this code into RStudio and then try to figure out how we can get this to actually display blue points. First of all, library ggplot2, and then paste in that code, and we should see the same code, the same plot as we did in the book, and sure enough we do. All right, so why does this not display blue points? The important point here is that we specify color equals blue inside of this ace function, this aesthetics function. And what you do inside ace is you map individual columns of your dataset to certain aesthetics. So for example, this L here is a column within this MPG dataset, and we map it to the x-axis. The same or similar we do for the HWY column, again coming from the MPG dataset, and we display it on the y-axis. And then with color we do something different. We specify this constant value of blue. Now this is obviously not a column within the MPG dataset, but what you have to think of it is kind of we're creating a new column on the fly that has blue, this constant, for every record in our dataset. So if MPG has, I think, 211 rows, then think of it as we're creating a new column where for all these 211 records, the value is blue. And since this then now becomes a column of the dataset, when we map this to color, what ggplot2 does is automatically it maps each distinct value of that column to a certain color. So blue is now just a value, just like, for example, Mercedes could be a model in the model column of MPG, a value. And now here all values are blue now, and it maps it to the first color within a certain color palette. And by default, that's this kind of pinkish color that we see being displayed here in this plot. So if you actually want to display blue points, what you have to do is you have to move this color equals blue outside of the ace function. So if I close the parentheses of ace directly here after this HWY, and then I remove one parenthesis here at the end, now color is outside of ace, but still within geom_point. And if we do that, we will see that actually now the points are blue, just like we intended to do. So if this happens to you, don't worry at all. This happens to experienced ggplot2 users all the time, but now you know kind of why and what you have to do about it. If you want to map a constant color to your points, or just rather simply say, if you want all points to be displayed in a certain color, put color outside of ace. And if you want to map the values of a column to different colors, then do that inside ace. And we will see an example in the second exercise, I believe. Okay, so second question. Which variables in MPG are categorical and which are continuous? How can you see this information when you run MPG? Okay, so let's just do that. Let's run MPG. Hit enter. And we get this nice display of our data. And notice that under each column name, we have inside of these angle brackets always like a three-letter code. The first one is CHR, which stands for character. So the manufacturer column is of type character. The model column as well, but then this displ column is of type DBL, which is short for double, and that's a fancy name for saying that these are numbers that have a decimal or a fraction. And then we can see year is of INT, which is short for integers, so whole numbers. And the same is true for sil. And then we have again character for trends and so forth. So all these character columns, it's a kind of the categorical variables, and both double and integer are our numeric columns. And sure enough, you can do it like this, and with only 11 columns, you have can fit almost all of it on one page here. You can see that only the class column could not be displayed here. But obviously, if you have a very large data set, you don't want to display the whole data set and then kind of manually count, okay, so the first character column, the second one, and so forth. So if you want to act a bit more programmatically, what you can do is to use the sapply function. And you pass it as the first argument, this capital X, the data set, so MPG, and then the second argument, capital FUIN, which is short for function. You now say, I want to apply this function to every column of the data set. And for example, we can say is.character. So we apply the is.character function, which tells us whether or not a variable is of type character, to every column within this data set. And you can see the result. So we get back a named vector. So manufacturer, sure enough, the result is true. This is a character. For model, the same. But for dispel and year and cylinder, we get false. And we can do the same thing, not saying we want to know the character columns, but the numeric ones. And just to note, numeric returns true for both double and integer columns. And now we get kind of the reverse. We can see manufacturer was true, but now it's false. Model is now false, but dispel, year, and cylinder are true. And finally, if you want to know like total number of numeric columns, for example, what you can do, and this is a really neat trick, you can sum up all these values. So if you use the sum function, you can see we get the number 5. And if you count this, sure enough, we can see 1, 2, 3, 4, 5 true values. Now you might be thinking, how can you sum up trues and false? And what you have to know is that what R does when it calls sum on a logical vector is it turns all true values into ones and all false values into zeros. So you can do the same thing. In the console, you can say as.numeric and then give it true as input, you get 1. And if you get false as input, you get 0. And that's why this kind of trick works. And if you wanted to know the total number of character columns, just replace the is.numeric function with is.character. And we can see we get 6. And 6 plus 5, sure enough, gives us 11, which is the total number of columns in this data set. Okay, next up, on to question number 3. And now this goes back to the first question in this aesthetic mapping. So it says map a continuous variable to color, size, and shape. How do these aesthetics behave differently for categorical versus continuous variables? All right, so I'm going to hit the up key to get back my ggplot2 command. And there you have it. And now I will not pass color to be a constant, but rather I will say, let's, for example, choose the DRV column. So this is a character column, a categorical one. And if we do that, you can see that for each distinct value of DRV, and there are 4 in total, we get a different point color. So this is what happens when you map a categorical column to the color aesthetic. On the other hand, if you use a numeric column, for example, let's choose dispel and choose another column for the X aesthetic, for example, let's go with year. So now you can see something very different. So dispel is numeric, and we can kind of see that we get a color gradient. So the high numbers are this lighter blue, and then the less the value gets, the darker this blue is. So that's kind of the big difference between mapping a continuous or a categorical value to the color aesthetic. Okay, now let's choose not color, but for example, shape. And now all points are again in the default black color, but you can see that we have triangles, we have squares, and we have points. And sure enough, the legend now looks like this. All right, so that's it. I'm going to continue with the rest of the exercises in the second part of the video. If you did like this video, make sure to leave a like down below. And if you want to see more videos in this series, please let me know in the comments. Thank you so much for watching. Cheers.